Good afternoon, and welcome to the 5th seminar in the NASA Administrators series of discussions about our future in space. Our subject today is sustaining life on the Earth, and our speakers are Dr. Diana Liverman from Penn State University and Dr. Robert Cates, an independent scholar. The first question that we might want to ask of our speakers is, what does sustainability mean? It might mean different things to ecologists, for whom the emphasis is on biodiversity, environmental quality, and climate protection, and to economists, for whom the emphasis might be on the improvement of human living standards. The different perspectives on sustainability may cause confusion in communicating its relevance to people and in deciding on appropriate responses to the challenges it contains. Is there a good measure for sustainability? It's not the gross national product, as Robert Kennedy pointed out some 3 decades ago. He said the gross national product includes air pollution and advertising for cigarettes and ambulances to clear our highways of carnage. It includes the destruction of redwoods and the death of Lake Superior. It grows with the production of napalm and missiles and nuclear warheads. And he went on to say, and if the GNP includes all this, there is much that it doesn't comprehend. The health of our families, the quality of their education, the decency of our factories, and the safety of our streets. It measures everything except that which makes life worthwhile. Beyond the ambiguity of what sustainability means, or maybe because of it, there's a disagreement about the prospects for achieving sustainability. Are we winning or losing the battle? What's the evidence? Some scholars question whether sustainability is even a significant issue, pointing out that humankind consistently has managed in the past to avoid the global specter of Malthusian scarcity through resource substitution and technical ingenuity. Others believe, however, that the scale of human pressure on natural systems already is well past a sustainable level. They point to Rwanda, Somalia, and other poverty-stricken areas as early signals of a pending decline of society's standards of living. Our speakers are interdisciplinary scholars who are engaged in defining a practical trajectory that will provide a long-term vision for a sustainable future. Sustainability requires much broader participation than the natural sciences alone. The present one of our speakers, Dr. Cates, has written, represents an exciting time for social and behavioral scientists to join with natural scientists to understand the interactions of nature and society, and technology in developing the method and the theoretical models to address the profound questions of society and its sustainability. Dr. Cates has pointed out that we need to consider the entire panoply of global changes now underway and not simply equate global change with environmental change. The problem of achieving sustainability is a great one that can be met with international understanding, evolving technologies, and individual commitment. Dr. Cates is our first speaker. He prefers the title of independent scholar, but he also happens to be a professor emeritus at Brown University. He is a world geographer, a distinguished scientist, and a widely published author. He is past president of the Association of American Geographers, executive editor of Environment magazine, and co-chair of Overcoming Hunger for the 1990s. His research and professional interests include world hunger, population, dynamics, sustainability of the biosphere, climate impact assessment, and the theory of human environment. He is a recipient of numerous distinctions, among them the National Medal of Science. That award was given to him for, quote, his fundamental contributions to the understanding of natural and man-made hazards, global environmental change, and the prevalence and persistence of world hunger. He's one of the very few social behavioral scientists to win this very distinguished award. He's also a recipient of the MacArthur Prize Fellowship. He's a member of the National Academy of Sciences and the American Academy of Arts and Sciences, and a fellow of the AAAS. Now I welcome Dr. Robert Cates.
Thank you. Last year, I was asked by Scientific American to address the question, can life be sustained on Earth? My answer was typically academic. Yes, no, maybe. I wrote, if life on Earth is the sum of living things, organic matter capable of reproducing itself, then the answer is almost assuredly yes. For life on Earth has over the eons of time survived repeated catastrophes that include essential atmospheric change, continental creation and separation, and asteroid collision. Life will almost surely go on, at least until the final dimming of the light in a cooling sun. But if life on Earth is life as we know it, the mix of living things that fill the places we are familiar with, then the answer is almost assuredly no. For human-induced change in the landscape, in the environment, and in the great biogeochemical and hydrological cycles now rivals that of nature. More than half of all such human-induced change over the last 10,000 years has occurred in our lifetimes and is still increasing. And if by life we mean us, our species, and the life that supports us, then the answer is perhaps. For human life has never really been simply onward and upward from the cave. Human numbers have grown by fits and starts. Human civilizations have declined and fallen. And even the human physique has fluctuated over time. But in the 150 years of Scientific American's existence, human numbers have quadrupled, and human consumption and technology have transformed the Earth. The coming half-century will be a critical period for human life and the life that sustains us. If we can manage the transition to a warmer, more crowded, more connected, but more diverse world, then there may be a promise of a sustainable future. It is that transition that I call the sustainable transition, and that's what I want to talk about today. We are, of course, living in an age of transitions. The health transition from early death by infectious diseases to late death by cancer, heart attack, and stroke. The transitional economies, moving from state to market control. The civil society transition, moving from single-party, military or state-run institutions to multi-party politics and a rich mix of non-governmental institutions. But transitions enter our rhetoric with the demographic transition, of which Europe was perhaps the earliest and the best studied. The Swedish transition, for example, took over 150 years to complete, with a steady decline in death rates followed by a decline in birth rates that begins 75 years later. In that interim, population numbers surge, and indeed an enormous Malthusian crisis begins around 1830 and prompts the large emigrations to North America. For much of the rest of the world, as exemplified by Mexico, the transition is incomplete, and we are still in the midst of the population surge phase. Yet even while populations surge, births decline. In 1950, the global average of children born per woman was 5, more than twice the 2.1 births required to achieve eventual zero population growth. Current births average 3.2 today, more than halfway there in the transition to a stable population. The death transition has been more rapid, of course, and life expectancy currently at 65 years, having grown to about 2/3 of the transition between a life expectancy at birth of 40 years to one of 75 years. It is that difference, of course, between the more rapid decline in deaths and the slower decline in births that adds about 88 million people each year to our numbers. But sometime in 1964, the growth rate of world population peaked at an estimated 2.1%. And it is likely that never before and never again will the population of the world grow so rapidly. If we must choose a time to date the subtle shift in the perception of crisis, the tilt in the constant tension between optimism and pessimism in the assessment of great problems, then that might have been such a moment. What weighed in the balance was the assurance that the end of the population explosion was in sight, not merely in the theoretical models of the demographers, but in the bottom line of the summation of life and death. Though there seems to be little question that the global demographic transition continues, much depends on its pace. What concerns us is not simply the impact of human numbers on the natural systems that support life, but the rapidity of such changes, a rapidity that is already evident over the last 50 years. There is a history of efforts to take stock of human impacts on Earth. It has been a specialty of the scientific tradition of geography in which Diana and I share. It begins in 1864 when George Perkins Marsh published his assessment as Physical Geography, or the Earth as Modified by Human Action, a remarkable study that would serve as the basis for modern concerns with conservation, resources, and environment. 92 years later, a fresh assessment entitled Man's Role in Changing the Face of the Earth was undertaken. And now the most recent stocktaking was organized in 1988. The international collaborative effort, published as The Earth as Transformed by Human Action, took stock of the magnitude of human-induced change over the last 300 years, but placed these changes in the context of the last 10,000 years. It differed from the previous efforts in that it sought to estimate human impacts on the great flows of energy and materials, as well as the stocks of land, water, and biota that the previous efforts had assessed. A sampling of the Earth Transformed findings show that since the dawn of agriculture, 10,000 years ago, an area the size of the continental U.S. has been deforested by human effort. Today, half of the ecosystems of the ice-free lands of the Earth have been modified, managed, or utilized by people. The flow of materials and energy that are removed from their natural settings or synthesized now rival the flows of such materials within nature itself. And water, in an amount greater than the contents of Lake Huron, is withdrawn each year for human use. All told, the Earth Transformed project was able to reconstruct human-induced changes in 13 worldwide measures of chemical flow: carbon, carbon tetrachloride, lead, nitrogen, phosphorus, and sulfur, and measures of land and water, deforested area, sediment flows, soil area loss, and water withdrawal, and measures of biotic diversity, floral, marine mammals, terrestrial vertebrates. We found that most of the change in these 13 indicators has been extraordinarily recent. For 10 of the 13 measures, half of all the change over the last 10,000 years took place within our lifetimes. So much for the immediate past. What now holds for the future? For almost 2 decades now, United Nations, the World Bank, and individual demographers that make 50 to 150-year forward population forecasts have projected a world population of between 10 to 12 billion that stabilizes sometime within the next century. Such agreement needs to be taken with many proverbial grains of salt, since all the forecasters seem to use similar methods and assumptions, and upward creep is more likely than downward error. Upward creep is already evident in the latest projections. But even a doubling of population may be too much. Doubling a population of Africans, Chinese, or Indians with their current consumption may be manageable, but doubling a population of Americans, Europeans, and Australians, and their consumption is not. In 1989, an International Institute of Applied Systems Analysis summer study found that current trends, or, quote, business as usual projections, for a doubling of population requires a quadrupling of agriculture, a sextupling of energy, an octupling of the economy, if varied and nutritious diets, industrial products, and regular jobs are to be in reach for most of the 10 billion people. Now, many find this 2-4-6-8 scenario unbelievable and certainly unsustainable because of the extraordinary increases in production and consumption required by just the doubling of population. Such increases, they think, could not be accommodated by current technology and practice in a human environment that has already seen substantial transformation of its atmosphere, soils, groundwater, and biota. But most of us, on reflection, recognize the unique situation that we are in. For an extraordinary short period of time, a matter of decades, human society will need to feed, house, nurture, educate, and employ at least as many more people as already live on Earth. It is if in such a warmer, more crowded world, environmental catastrophe is to be postponed, it can only be done by either maintaining great inequities in human welfare or by adopting very different trajectories for technology and development. How likely are we to have such different trajectories for technology and development? How might such a transition to a sustainable world take place? Currently, there are three current, contrasting, and archetypal visions of such a transition. And while we like to boast about how new everything is, these are rooted in the great 18th and 19th century figures, Robert Malthus, Adam Smith, and John Stuart Mill. But they are also as current as today's books and magazine racks. Malthus thought there were three checks to population: moral restraint, which included late marriage and abstinence, and which he advocated, but was skeptical of its wide acceptance; vice, which included contraception and abortion, which he could not accept; and misery, which he described as follows, and I quote, "All the causes which tend in any way prematurely to shorten the duration of human life, such as unwholesome occupations, severe labor and exposure to the seasons, bad and insufficient food and clothing arising from poverty, the bad nursing of children, excesses of all kinds, great towns and manufactories, the whole train of common diseases and epidemics, wars, infanticide, plague, and famine." Now contrast Malthus's dismal sketch with the recent one on the future drawn by Robert Kaplan and described on the cover of the Atlantic Monthly as the coming anarchy. Nations break up under the tidal flow of refugees from environmental and social disaster as borders crumble. Another type of boundary is erected, a wall of disease. Wars are fought over scarce resources, especially water, and war itself becomes continuous with crime as armed bands of stateless marauders clash with the private security forces of the elites, a preview of the first decades of the 21st century. Thus, the first of the visions of the sustainable transition is the miserable vision. Population numbers and consumption are checked by the four horsemen of the apocalypse. Mill would write in 1848, and the Meadows, Dennis and Danella, and Jorgen Randers would quote in their recent book from John Stuart Mill, "I cannot regard the stationary state of capital and wealth with the unaffected aversion so generally manifested toward it by the political economists of the old school. I am inclined to believe that it would be on the whole a very considerable improvement in our present condition. I confess that I am not charmed with the ideal of life held out by those who think that the normal state of human beings is that of struggling to get on, that the trampling, crashing, elbowing, and treading on each other's heels are the most desirable lot of humankind. It is scarcely necessary to remark that a stationary condition of capital and population implies no stationary state of human improvement. There would be as much scope as ever for all kinds of mental culture and moral and social progress, as much room for improving the art of living, and much more likelihood of it being improved. They then update their earlier work, that's the Meadows and Randers, which was the limits to growth, and describe in Beyond the Limits a sustainability transition. Using their world model, they simulate a sustainable world with deliberate constraints on growth. The model world, and I quote from them, decides on an average family size of 2 children, beginning in 1995, has perfect birth control effectiveness, and has decided to aim for an average consumer goods per capita of 1968, $350 per person per year, about the equivalent of that in South Korea, or about twice that the level of Brazil in 1990. Furthermore, starting in 1995, it begins to employ technologies that increase the efficiency of resource use, decrease pollution emissions per unit of industrial output, control land erosion, and increase land yields until food per capita reaches its desired level. The resulting society sustains 7.7 billion people at a comfortable standard of living with high life expectancy and declining pollution until at least the year 2100. Such a sustainable society does not necessarily mean the population and economy are static or stagnant. They stay roughly constant the way a river is roughly constant, though new water is always running through it. In an equilibrium society, people are being born while others are dying. New factories, roads, building machines are being built a while old ones are being demolished and recycled. Technologies are improving, and the steady flow of material output per person would almost certainly be changing and diversifying in content. As a river may have ups and downs around some average flow, so could an equilibrium society vary either by deliberate human choice or by unforeseen opportunities or disasters. Thus, for the Meadows, a sustainable transition is a transition to an equilibrium society where there are constraints on the growth of population and material output, but not on development. A final vision of the sustainability transition is of a continuous transition, one guided by an invisible hand. In its most extreme form, it is described by Simon as, and I quote, "The standard of living has risen along with the size of the world's population since the beginning of recorded time, and with increases in income and population have come less severe shortages, lower costs, and an increased availability of resources, including a cleaner environment and greater access to natural recreation areas. And there is no convincing economic reason why these trends towards a better life and towards lower prices for raw materials should not continue indefinitely. There is no physical or economic reason why human resourcefulness and enterprise cannot forever continue to respond to impending shortages and existing problems with new expedients that after an adjustment period leave us better off than before the problem arose. Adding more people will cause us more problems, but at the same time there will be more people to solve these problems and leave us with a bonus of lower costs and less scarcity in the long run. The bonus applies to such desirable resources as better health, more wilderness, cheaper energy, and a cleaner environment." Now, Simon's faith in the forever is extreme, but many economists and technologists share in his vision that the invisible hand of rising prices will curb consumption and encourage materials and energy substitution and invention. They are confident that human creativity can overcome all limits. I am not much of a purist in anything, and find it difficult to accept the solitary likelihood of any of the archetypal transitions. While much in love with great ideas and great ideals, be they Smith, Malthus, or Mills, I fear the actual pathway of a successful transition, indeed, if we can succeed, will probably follow that path of decision and action that Lindblom called muddling through, or more appropriately, lurching through. And to do so, it will surely embody some elements of all three visions. Let me restate the unique and enormous challenge of the next 5 decades. In this extraordinary short period of time, human society will need to feed, house, nurture, educate, and employ at least as many more people as already live on Earth. Even or especially to lurch through will require profound change in our institutions, technologies, and belief systems, and more than a smattering of good fortune. Fortunately, new institutions, new technologies, and new ideas are already in place, suggestive of the different trajectory of technology and development that a sustainable transition might follow. There are even a few signs of fortune. 3 sets of important transnational institutions are emerging. The best known are those created by governments, a set of international organizations, treaties, and activities. Currently addressing the environment, there are some 170 international treaties in force, and there are new international institutions, such as the United Nations Commission on Sustainable Development, that is to oversee the accords of the Earth Summit in Rio, or the Global Environmental Facility that combines the talents and wealth of the World Bank and the United Nations Development Program and the environment programs. Equally well known, but not for its pro-environmental dimension, is the transnational corporation. The activities of such corporations are responsible for much of the human-induced change taking place around the globe. But increasingly, they are also disseminators of common approaches, technical skills, and standards for addressing environmental problems. And finally, least studied, but in many ways most important, is the veritable explosion of transnational, non-governmental, and private voluntary environment and development organizations and their local counterparts in developing countries. An estimated 200,000 groups increasingly linked together in international networks. Despite the current mood in Congress, some favorable results of these institutional changes are already apparent. In the Earth Transform project, we found that the rates of increase for 5 of the 13 transformations studied have now turned downward. Vertebrate and marine mammalian extinctions and releases of lead, sulfur, and carbon tetrachloride. All of these have been subject to strenuous regulation by the wealthier countries, but increasingly in developing countries as well, spurred on by all 3 of the new institutions. There are also discernible long-term trends in some technologies, doing more with less. Since the mid-1800s, the amount of carbon used in producing a unit of production has been decreasing by 1.3% per year by a combination of using less carbon-rich fuels to produce energy and using less energy overall per unit of production. Nonetheless, this has not been sufficient to offset the growth of the economy per year, leading to a global increase in CO2 emissions in each year. There is also a similar but more complicated trend towards dematerialization, using less materials overall per unit of production. Perhaps like using smaller and smarter satellites. Thus, we are clearly using less steel and cement, but more aluminum and chemicals, although these have peaked and are beginning to lessen. And while despite the computer and television revolutions, the use of paper remains constant. In a more crowded and more consuming world, one mode of coping is to use a smaller throughput of the basic ingredients of energy, materials, and information that sustain life and meet the enlarged needs and wants of human society. As shown by the long-term trends, there has already been a reduction of energy and materials required per unit of economic output, but there is great potential to accelerate such trends. Simple interventions include the recent competition to build a low-energy consuming, non-ozone depleting refrigerator in the US, or to move immediately to next-generation refrigeration in India. Longer term, there's an emerging field of study and action known as industrial ecology that seeks to use the mechanisms of market, competition, and efficiency to minimize the throughput of energy and materials and the output of waste from industrial processes. Several major corporations have really adopted as a goal total recycling and internal circulation. Still longer term, there is great opportunity to increase human sustenance without increasing environmental burdens through the science and engineering of biological processes, new energy sources and transmission, new materials, and the substitution of information for energy and materials. And most promising in the long run is work on the molecular and submolecular technologies, microelectronics, biotechnology, and nanotechnology materials. Potentially more important than institutions or technology are the emergent ideas. Sustaining human life on Earth requires at least three important sets of ideas: that cohabitation with the natural world is necessary, that there are limits to human activity, and that the benefits of human activity needs to be more widely shared. Last winter, I attended a concert of 500 school children voices, my grandchildren included. What was most striking to me was the relative absence of the patriotic hymns of my childhood, and their replacement by a new set of environmental hymns and anthems. And I came away wondering how 25 years of Earth Days has changed the formative ethos of young Americans. But this was Maine, and what about the rest of the world? A recent study undertaken by Riley Dunlap and the Gallup organization compared opinion in 12 industrialized and 12 developing nations, including Eastern Europe, and found surprisingly little difference in the attitudes found in those nations. Indeed, even the attribution of the cause of environmental problems, whether it was overpopulation or consumption of the world's resources by industrialized countries, they were seen contributing equally, both by residents of rich and poor countries. And along with this widespread, but sometimes fluctuating evidence of environmental concern, more profound and fundamental ideas are emerging. These are found in the burgeoning of ideas and movements that include fundamental challenges to anthropocentrism, as well as more modest efforts to resolve the conflicting needs between ecosystems and economies, or the conflicting claims of equity between species, places, peoples, livelihoods, and generations. My hope for good fortune rests in part on the good news, bad news biases that seem to affect even the best of scientific research. For more than 150 years, scientific research seemed to ignore or downplay the negative effects of emerging technologies. It was a period that ended with Rachel Carson. Today, I detect an apparent bias in research to identify the harmful effects and the mechanisms that amplify the impacts of people, places, and things, and only later to discover the negative feedbacks or compensatory adjustments that modify the harmful impacts. It is a subtle rather than an overt bias. Science is too honest to deny such feedbacks or adjustments, but it is not as active in searching for them as for the harmful effects. An example of such belated recognition is the recent documentation that forest biomass in Europe is not only surviving, but probably increasing, despite enormous burdens of pollutants and acid rain. This may be occurring because of the fertilization effects of the very same chemical pollutants, which as aerosols also seem to provide a counter greenhouse warming effect. I might note that remote sensing has been most important in documenting the increase in biomass in Europe, as has been the work supported by NASA on estimating realistically the pace of deforestation in the Amazon, which other estimates have tended to exaggerate. Such cautionary tales serve to remind us that we often do not understand the impacts of human-induced changes on natural systems, sufficient to know to what degree important life support systems are threatened, or what replaces such systems when they are degraded. Nature may be more robust than popular rhetoric is willing to concede, and our belated recognition of that condition may constitute good fortune. But there is more to good fortune than favorable surprises. 15 years ago, Lionel Tiger suggested that there was a biology of hope, an evolutionary human tilt towards optimism that compensates in part for our very ability to ask questions, to have a seminar such as this, to ask, can human life on Earth be sustained? While I'm unpersuaded by his somewhat tenuous chains of argument, I share his inclination. Not because I have great confidence in the invisible hand of the marketplace, or of technological change, or of even Lovelock's Gaia principle, in which life itself seems to create the conditions for its own survival. Nor is it just the important and rapid acceptance of sustainability as a basic goal for human society. Rather, it is because hope is simply a necessity. If we humans, now conscious of the extraordinary challenge that we face in the coming years, are to negotiate the sustainability transition. Thank you.
Thank you, Dr. Cates, for giving us the moral dimension of this problem. Our second speaker, Dr. Diana Liverman, is an associate professor of geography and an associate director of the Earth System Science Center at the Pennsylvania State University. Her research interests include the interaction between climate and society and global environmental issues. She has covered a lot of geography in getting her degrees. She started with a BA from University College London, then received her MA from the University of Toronto, and ever westward got her PhD in geography from UCLA. Her research interests are in climate and society, Mexico and the impacts of drought and climate change, and agriculture and land use there, and the human dimensions of global change. I had the great pleasure of interacting with Diana in a previous life when I was at Penn State University. A couple of years ago, she asked me to address a large group of her geographer colleagues on the subject of the sustainability of black holes and neutron stars in accretion-driven binary systems. Today, I have the pleasure of introducing her to speak on the sustainability of a more local environment, one which is accreting more than just gas. Diana.
Bob Cates, always the visionary, has identified a great challenge to sustaining life on Earth, the growth of the human population. He also hints at some optimistic trends in institutions, ideas, and technology that he hopes will help us find ways to a more sustainable future. I'm going to try and ground and calibrate his vision and our future by looking at one country, Mexico, which provides a dynamic and dramatic case of the human dimensions of global environmental change. I will examine the role of population growth in the transformation of the Mexican environment and in increasing Mexico's vulnerability to global change. I will also try to find some reasons for optimism about the future of Mexico and similar regions. When appropriate, I'm going to try and illustrate my remarks with specific examples of research which links the social and natural sciences and combines physical and social data to better understand the social causes and consequences of environmental change in Mexico. Mexico's rapid industrialization and population growth are placing tremendous stresses on the resource base of water, soils, and biodiversity. Mexico is a significant producer of greenhouse gases and a globally important reservoir of biodiversity. Another reason for focusing on Mexico is that the Mexican government has often positioned itself as a leader amongst developing nations in environmental policy and negotiations. The first to sign the Montreal Ozone Protocol, Mexico has eagerly sought technology transfer for greenhouse gas reduction and international support for forest conservation. As our southern neighbor, Mexico is of enormous strategic importance to the United States. Our third most important trading partner, financial and market integration is growing with the implementation of the North American Free Trade Agreement, NAFTA. People, water, and pollution flow across the shared border. The rapidity and volatility of recent political and economic change in Mexico, including the Zapatista rebellion last year, assassinations, and the collapse of the peso, have raised significant concerns about the relationship between economic and environmental policy, the sustainability of agriculture, and the environmental basis of migration and conflict. To what extent can Mexico's contributions to global changes in climate and biodiversity be attributed to population growth? Carbon emissions, as you can see in this graph, have grown steeply over the last 20 or so years. The activities responsible for these emissions include fossil fuel and cement production and deforestation. Methane trends are similarly moving upward as a result of livestock and gas production. Renewed attention to emissions data as a result of the Intergovernmental Panel on Climate Change process and an recent EPA coordinated country study suggest that population growth is only partly responsible for these trends. Greenhouse gas emission increases in Mexico are also correlated with some of the factors that I show on this graphic, including tremendous growth in exports of cattle and oil, and increased per capita consumption of energy and materials. And you can see this because the slowing of emissions in the late 1980s is associated with drops in consumption, per capita consumption during economic crises, rather than any temporary slowdown in population growth. Estimates of emissions are also emerging as highly uncertain. For example, the preliminary results of the country study indicate that methane emissions are probably much lower than previously thought because of discrepancies in the livestock census and much lower per capita animal emissions from poorly fed tropical animals. The uncertainty in carbon dioxide emission estimates in Mexico is partly associated with a great divergence in estimates of Mexico's deforestation rate, which in the country study ranges from 300,000 hectares to 800,000 hectares a year, depending on whether census or satellite imagery is used and by whom. Forecasts of future forest cover, important in estimating emissions, assessing joint implementation, which is the process by which northern countries can count reductions in carbon emissions if they contribute to reforestation efforts in other parts of the world. So these forecasts of future forest cover are very important in estimating emissions, looking at the effectiveness of joint implementation, protecting biodiversity, and understanding regional hydrology. These forecasts of future forest cover are difficult because we lack information about the social forces driving land use transformations. In order to project forest cover into the future, we need to understand the human activities that are lying behind these forces. In the state of Chiapas in southern Mexico, we have tried to resolve the uncertainties about the rate and causes of deforestation with support from the National Science Foundation and NASA. Agricultural census and archival data suggested significant conversion from forest to pasture and cropland, as indicated in this graph. Analysis of TM and MSS scenes made available through the North American Land Cover Pathfinder project allowed us to document land cover changes over the last 20 years, compare it to what we could see in the census, and identify key areas for field investigation. We are using the data set on forest cover and land use change to ask several questions of relevance to global change research. We have examined meteorological station records in forested and deforesting regions to see if there's any evidence that land cover change is altering the regional climate in southern Mexico. We're also linking the land cover data to socioeconomic information within a geographical information system in order to assess the relationship between deforestation and variables such as population growth, migration, and poverty. In this analysis, we plan to use a georeferenced demographic data set available through season. Other researchers are using the data set in ecological studies of forest fragmentation and species habitat. One of the species that is being severely affected by deforestation in the region is this stunningly beautiful bird, the scarlet macaw. In all studies, we are trying to undertake cross-scale analysis and validation by, for example, conducting local-scale microclimatic transects from forest to clearing, and by interviewing local people about their perceptions and explanations of land cover change. We are hoping to expand and link our analysis to the recently approved IGBP HDP core project on land use and land cover change. This international and comparative project of the International Geosphere Biosphere Program and the Human Dimensions Program, both international initiatives, this project sets out to document and model the dynamics and patterns of global land transformation and the underlying social driving forces. It seeks to provide improved information to scientific assessments of changing albedo, biogeochemical cycles, greenhouse gas emissions, and hydrology, as well as to local level decisions about land use management. We also hope to link to a project, Global Change in Local Places, of the Association of American Geographers, which sets out to uncover the local scale causes and trends in greenhouse gas emissions. In Chiapas, it is clear that the causes of land cover change are highly complex. The statistical studies that we've undertaken, as well as some of these images that I will show you here, show that there are numerous factors, including population growth, that are contributing to the deforestation of the region. They include timber extraction for domestic construction and tropical hardwood export. The expansion of commercial ranching and coffee production, also often for export, oil exploration, and in-migration of settlers from conflict-ridden areas of Guatemala and other regions of Mexico. Other factors include highly unequal distribution of land and income, and, as Bob Cates might expect, the highest population growth rates in all of Mexico. In addition to explaining environmental degradation and greenhouse gas emissions, these factors that I've talked about, inequality in land and income, the expansion of export crop production, these types of factors also lie behind the Zapatista rebellion that occurred in the region last year, and in a sense link this process of environmental change to some process of social unrest and conflict within the developing world. Are there any grounds for optimism concerning deforestation in Mexico? Perhaps. Much of the remaining forest in Chiapas is protected by the Montes Azules Biosphere Reserve. The Mexican government has also started to provide more resources to the region to alleviate poverty and provide alternative employment in the region. Mexican and international scientists are working to monitor the environment of the region and identify more sustainable ways of using the land. There is some evidence that rates of population growth are slowing in this region, and there are also large numbers of reforestation projects, some with international assistance, that are taking place within the region. Another source of optimism that Bob Cates also referred to is growing awareness of the need for environmental protection on behalf of the population in Mexico, and specifically the children who in this slide are visiting the ecological reserve adjacent to the forest in Chiapas. Moving now from an examination of the social causes of global change in Mexico and from the southern region of Mexico to the central and northern regions, I'd now like to move from looking at the social causes to looking at some aspects of the consequences of global and climate change in Mexico. I'd like to discuss how population growth and economic development are changing vulnerability to climatic change and variation in Mexico. Whilst the bulk of global change research has focused on monitoring and modeling the biophysical aspects of the Earth system, there has been relatively little attention paid to how changes in social and economic systems are altering the conditions under which society experiences climate change and variability. Many regions of the world are becoming more vulnerable to warmer, drier conditions and to extreme events because there are more people, more industries demanding more water and occupying more hazard-prone land. In many places where climate models cannot agree about whether rainfall will increase or decrease as a result of global warming, social scientists can be pretty certain that by the time carbon dioxide doubles, there will be twice as many people hoping to consume twice as much water per capita. This has been modeled for the Colorado River Basin and for the basin in which Mexico City lies. We are also fairly confident that trends in urbanization, coastal development, and agricultural intensification are putting larger amounts and percentages of people and productive activities at risk from the droughts, floods, and hurricanes associated with interannual climate variability. I believe that social science research on vulnerability and ways to reduce it is important not only to national policymakers, but also to regional resource managers, local communities, and industries such as insurance, commodity, utility, and transportation sectors. Again, let me illustrate my points with some examples from Mexico. This year, northern Mexico has experienced the worst drought in more than 50 years, and temperatures well above the long-term normal. Many reservoirs in northern Mexico are at less than 20% of their capacity. Hundreds of cattle have died, and thousands of hectares of land have not been planted. The drought has also been linked to increased number of migrants trying to cross the border into the US. Unfortunately, the drought has coincided with a serious economic crisis in Mexico. Prices for agricultural inputs, seeds, and fertilizers have been steadily increasing for a number of years. Public credit and subsidies for agricultural inputs and to purchase guaranteed prices for crops have also been declining, as shown here, as the Mexican government reduces public sector spending and moves to privatization and free markets. In January, the value of the peso fell precipitously and interest rates soared. This year, farmers cannot afford to buy seeds and fertilizer, and many of the poor cannot afford to purchase enough food. Reports based on satellite and field observations suggest that less than 60% of the usual crop area had been planted by May 20th. Farm livelihoods, the nutritional status of the poor, and Mexican food security are extremely vulnerable to this combination of economic and climatic crisis. We have analyzed such intersections of interannual climate variability and socioeconomic vulnerability in several other regions of Mexico, with some support from the National Science Foundation. In the Valley of Oaxaca, for example, synoptic climatology and station data show a strong correlation with crop yields in the valley, especially in El Nino years like 82, 83, 86, 87, and the recent years. But changes in the socioeconomic system have been much more important in influencing drought vulnerability of several groups in the valley, particularly through influencing their access to groundwater for irrigation. Deforestation of the hills around the valley has caused a severe drop in the water table of up to 10 meters in some places, and the tourist-related expansion of the city of Oaxaca has increased urban demand for limited water supplies, further drawing down the groundwater levels. The growth of urban and export markets for cheese and vegetables have altered crop practices on the private land. The farmers who can afford mechanical pumps have shifted to growing water-thirsty alfalfa for dairy cows, which produce milk for cheese. Other farmers are shifting to water-consumptive vegetables for export. The mechanical pumps draw down the water table to levels where poorer maize producers can no longer take advantage of near-surface water. They used to be able to pull the water up by hand. Years of low rainfall now intersect with increased competition and demand for water to create political conflict and subsistence crises within the valley, which, again, incidentally, has become a major source for migration to the border and to Mexico City. Changes in the type of crops grown have also increased water demand and vulnerability to drought in the irrigation districts of Sonora in northwestern Mexico. This map shows the irrigation district of San Luis Rio Colorado, just south of Yuma, Arizona, where there has been a major shift from growing basic grains like wheat and maize to crops such as alfalfa, fruit, and vegetables. This is some historical data that we developed from the reports of the irrigation district that show significant shifts out of growing basic grains into growing these crops like alfalfa and fruit and vegetables, very much for export. These shifts are forecast to continue and accelerate as a result of the North American Free Trade Agreement, because the withdrawal of subsidies for grain production in Mexico will probably make Mexican grain production uncompetitive with that of the US and will increase Mexico's comparative advantage in growing fruit and vegetables. Well, you may be wondering what this has to do with climate. Oh, this is just to show that not everybody in the region is happy with NAFTA. This says no to the free trade agreement. People are very worried about the withdrawal of agricultural subsidies, although this is balanced by large numbers of people who were very optimistic about NAFTA in Mexico. Well, you may be wondering about what all this has to do with drought vulnerability. The problem is that alfalfa, fruit, and vegetables have a much higher consumptive use of water than grain, and therefore increased demand for water in this arid climate. Urban and industrial development are also increasing water demand and hence drought vulnerability in the border region. Some parts of the irrigation districts have been abandoned because of the lack of good quality irrigation water. We have also used the output of several general circulation models to examine how global warming might affect Mexican agriculture and how global warming might interact with changes in population and vulnerability. Of course, our ability to project changes in the physical aspects of the Mexican hydrological cycle is severely limited by the uncertainty and resolution of the current climate models. Given all of the caveats of using climate model output, a study funded by EPA and conducted in collaboration with NASA GIS suggests that Mexican grain yields could decline significantly decline to perhaps 50% of current yields with a doubling of carbon dioxide in the atmosphere, even when we take carbon dioxide fertilization impacts on crop production into account. This work was done using crop models where you can adjust the climate, adjust the levels of carbon dioxide to investigate what the possible impacts of global warming might be. Now, what we found in the study is that the vulnerability to such a climate change, drying and lower precipitation in parts of Mexico, vulnerability to such a climate change could be reduced if farmers could adapt to climate change by using irrigation, fertilizer, and improved seeds, as shown in the top bar on this slide. However, as I have discussed, population growth, agricultural intensification, and economic conditions are even now limiting access to water and inputs in Mexico. Unless conditions change, the potential for adapting to climate change may be somewhat limited. Let me try to recover some of Bob's optimism in noting some ways in which vulnerability to climate variation and change might be reduced in Mexico and other regions. Improved modeling, monitoring, and forecasting of seasonal conditions, such as those related to El Niño, could very much help in water and agricultural planning in places like Mexico. The use of seasonal forecasts is already showing great benefits in northeast Brazil and southern Africa. Initiatives such as EOS show promise for improved understanding, monitoring, and management of the hydrological cycle in relation to croplands, rangelands, river flows, and reservoirs. I would also like to point out that Mexican scientists are eager to participate in these scientific activities and acknowledge the help of many Mexican collaborators in the research that I've been discussing. There are also moves to improve the efficiency of water use in Mexican cities and irrigation districts through infrastructural improvements, price adjustments, new institutions, information dissemination, and wastewater treatment. Plant breeders are developing improved varieties of crops that are less dependent on expensive inputs and more drought resistant. There is some acknowledgement that the recent changes in economic and political structure in Mexico, for example, in land tenure and agricultural subsidies, may have been too sudden and need to be more carefully and scientifically adjusted to regional, economic, social, and environmental conditions. In closing, I'd like to show this slide to acknowledge the many contributions of the students that have worked on the studies that I have described. This is our field team in Oaxaca, Mexico. And I would also hope that I've tried to give you some insights into the risks and opportunities in sustaining life in Mexico as a regional case study of the larger challenges facing planet Earth and its inhabitants. If I have disagreed in any way with Bob Cates, it's to argue that population is just one of the many social factors that we must consider in global change research. I've tried to show the ways in which social and physical factors and data can and must be combined in order to understand the past and plan for the future. In doing so, I've also attempted to show some of the ways in which information and support from NASA and other global change program agencies has been helpful in my research and, I believe, potentially to resource managers and decision makers here and in Mexico. Thank you, and I look forward to our discussion.
Thank you very much, Dr. Liverman. Now we're going to start our discussion. I'd like to invite Dr. Cates to join us, and also Dr. Kennel. Charles Kennel is the Associate Administrator for Mission to Planet Earth here at NASA. We'll start off with a couple of questions ourselves up here and then open it to all of you. There are 2 microphones on the side, and so after a few minutes you can start to line up, and then when we see the line forming, then we'll stop and ask you for your questions. I think I'll take the prerogative here and start with the first question. Diana, you mentioned in your talk a couple of ways in which the space agency or space programs in general can really help out with the problems in Mexico in particular. And you mentioned the hydrology studies and modeling, and also El Niño. And I was wondering, Dr. Cates, if you could comment on if there are other ways in which space can be used towards this challenge of sustainability.
I'm supposed to say, I'm glad you asked that question. I think that if you go to what I think of as the critical bits, in effect, the argument that there are critical changes in belief systems, institutions, and technologies, that have to take place, it seems to me that space-based science and engineering work such as NASA does probably has contributions in all of those. The obvious ones are obviously within the technologies. And I'm sure as I talk to you, especially about the long-term development of technologies and so on, there was resonance throughout the room with some things people are trying to do, whether it's to breed better crystals or to use less materials or to understand the nature of the Earth. There's also the systematic provision of what I consider progress reports, the sustainability, which is the only thing that will sustain us, if you'd like, in making the transition, for which space-based technology has really no replacement for. But the interesting thing is to look at the institutions and to look at the belief systems. Already, space-based technology has had probably a profound effect on the belief systems. That blue dot that we've show and re-show and play out has penetrated to every part of the world. And if we will make the sustainable transition, and while I tried to be optimistic, I tried not to be too optimistic, because I still think it's very much in doubt, it will be because that from the tremendous particularism that rides through the world, we begin to evolve to a much greater universal set of values. And there, that sense of the Earth as a whole is incredibly important. And finally, on the institutional sense, I think what is very clear is that official institutions are not as important as the network of institutional relationships that develop in every sphere: commerce, science, cooperation. It seems to me that there are tremendous opportunities as space-based science moves ahead, as it becomes truly international rather than emerges from its competitive phase, to provide many, many links that we'll need to back channels, ways of contacting, ways of tying ourselves together.
Diane, did you want to add anything to that?
That's a wonderful vision, and I think I agree with what Bob is talking about. But I do think that social scientists have not fully learned to take advantage of the products and the insights that are gained by NASA. And I think that we have a way to go to learn how to work together, how to integrate the social and natural data. Though at the level that Bob is talking about, I think that the vision of the planet, the vision of a planet that is linked and must work together is very important for all of us in science, and it really helps our ability to work with, for example, for me to work with scientists in Mexico to understand some of the problems.
I see countries and agencies within single countries like ours taking on this challenge, but the place where a lot of social change can and should happen is, of course, among our young people. And I'm thinking of our research and other universities now, and you're still on a university campus. You were on one recently. Why is it that on our campuses that we're still going along in our disciplinary ways and not making those kind of embracing liaisons that might give an extra impetus to this? I mean, I would think of all places that should be where this whole kind of vision takes hold, and without it, we're just not going to be able to charge up the whole public about it.
Well, at one level within the university, I think the problem lies with both the faculty and the students' unwillingness to take risks. Students will take their required general education courses, which sometimes are interdisciplinary, and then they get channeled into majors because they're quite rightfully concerned about careers. And in a way, I think students don't have visions of interdisciplinary careers at this point, and that perhaps is something that we need to work on to give them a sense that probably some of the most challenging jobs in society today are ones where you need insights from more than one discipline. Faculty, of course, We've been socialized into our disciplines and into the criteria of our disciplines. The tenure process judges your performance in your discipline. And whereas some universities have tried to create interdisciplinary institutes, it's still an effort and a risk and almost sometimes twice the work to try to be interdisciplinary. But I think that we are moving in that direction.
And I see that those kind of institutes that are created a lot of times have struggled getting the prestige that the straight disciplines have, and that's an impediment too. Did you have any comment?
The students are way ahead of the faculty. It's as simple as that. The demand for environmental studies, the demand for interdisciplinary work. At Brown University, there are 83 majors and only 39 departments. And so all the other majors are basically interdisciplinary concentrations. Faculty come from a different generation, a different worldview, and they belong to these ethnic tribes, intellectual ethnic tribes that we call disciplines. And that will change. Disciplines are only 100 years old. They kind of came to America in the late 1870s, 80s. And in the 2070s and 80s, we'll have something quite different.
But I would point out one of the most popular courses at Penn State now is the course on the Earth system that's taught by interdisciplinary faculty. It's probably putting 1,000 students a year, and it makes heavy use of interactive computer technology, remote sensing, output from global change research. And the students are really inspired by that sort of course. I think we need to work towards having more courses like that.
And to be serious, just to follow up, the model that will have to take place will be some model of recombination. We need to train new generations of students who will be able to change their foci in their lifetimes, who will be able to adjust to different risks and different opportunities. If we're going to make this and the model of how you recombine kind of recombinant intellectual DNA, that will have to become, we don't know how to do it yet. You're probably struggling internally here to some extent on how to do that. Everybody will be struggling how to do that. But that's what the nature of our future is, and actually my grandchildren will be much more flexible than I was.
Charlie.
Well, actually, both of you have answered most of the questions that I had
before
I get it. So but I do have one more, and I'll start. Diana, you gave us quite an interesting vision of, amongst other things, of the complex potential interactions between climate change and Mexican society, and how it might adapt, and all the factors that are involved in this issue. And I've seen a few, in my new job here, I've seen a few other things like that. And I understand the enormous proliferation of the knowledge that you need to have to make intelligent decisions. Now, we at NASA have a certain proprietary interest in the Earth. And, and we've been working for 10 or so years on a program that has focused on climate change. But to get to it, we had to focus on the elements of the Earth system that were parts of the climate. And from that, we had to and we did that because we know the elements of that Earth system, those elements were important to human beings. And the question is, are we on the right track? Do we need to do more? Would you, at this stage, knowing what you know now about the global change program, and if you could start ab initio, would you tweak our approach a bit? Would you add something? Would you ask us to reach out? What would you have us do in the next 10 years? Either one.
Well, that's an not easy question, or an easy question. I'll give you two. From what I know, I might focus a little bit more on interannual climate variability and extreme events, focus on understanding that as much on getting the long-term possible trends in global temperature. This is a comment more on global change research in general. And the reason for moving perhaps a little bit more towards interannual climate variability is that is what society is experiencing right now. And in fact, global change will be experienced as climate variability and extreme events. I think that we know that. So that's one shift. The other shift that concerns me a little bit is the way, to some extent, the global change programs focused on unmanaged ecosystems, on the parts of the Earth that are still perceived of as wild. And whereas, in fact, most of humanity is living in the managed ecosystems, and that's where a lot of the greenhouse gases are being emitted and where the vulnerability is occurring. So I also think it's important to keep that balance between managed and unmanaged ecosystems in any global change program. And then, of course, as a social scientist, I should say that we need to be making a greater effort to have the human dimensions of global change become an integral part of the global change program, and not something that's out there separately, because I think the links are really integral and that we can work together on those issues.
You mentioned in your talk that you wished basically that the climate models were somewhat better because you could make a better evaluation of the impact. But to what extent is it the case that if we did the things you suggested, that we'd make the climate models better? Do you think there's a possibility that that's a...
Well, yes. I mean, in terms of being able to get better parameterizations of land use change and understandings of regional hydrology, yes, I think that we can contribute by giving more accurate and perhaps dynamic assessments of how land cover is changing and will change in the future. And that's the initiative that lies behind this new land use, land cover change program that we all hope to be participating in. With regard to, I mean, I've been working in this area for almost 20 years, and I keep hoping for better information out of the climate models, and it is getting better. I mean, some of the things that excite me are the ways in which we may be able to use circulation information out of the climate models rather than, I'm getting rather technical here, you know, the grid squared temperature and rainfall results. Ways in which we might be able to, those of us who are interested in impacts on society could use mesoscale climate models nested in general circulation models. And also a wider range of variables. It used to be that we only used to get the temperature and rainfall results. Now we're getting solar radiation, humidity, soil moisture. All of those are much more useful in the work that I'm doing. So we're moving in the right direction. But I think the other point I want to make is that we can say quite a lot without having to wait until the climate models provide us with perfect results.
Well, I think probably I would, first of all, get rid of the notion as a beginning point that more research will reduce uncertainty, which is how we've sold ourselves over and over again. Not NASA, but the International Geosphere Biosphere Program has a glossy brochure that says reducing the uncertainties. And the fact is we know that that's absolutely untrue. More research will increase the uncertainties in the short run. And that's what's been happening continuously with us. And so that I would begin with that. But then why should society support us? We have to have some other arguments. I think there are two critical things here. I think the desire to see short-run outputs, to see things that can be useful in the short run, also comes about from expanding, making global change really global change. And if you don't define global change as simply global environmental change, and you don't define global environmental change as simply global climate change, then you have all kinds of other opportunities. The fact is that even major global climate change may not hurt most people unless it's also accompanied and in the ethos of the other enormous global changes that are occurring of all sorts, some of which I alluded to. We have massive restructuring taking place at every range throughout the world, and it's only the coexistence, as we heard so well in the Mexico case, of the simultaneous occurrence of a drought, of a change in the economy, of rapid population growth, that the real threat for Mexico lies, and not simply in the sole existence of the drought. So we have to work that into our armamentarium. And then I think finally, probably the most important thing is communicating with our publics. I think one of the big steps, when the whole effort started of global change, you listened to the scientific community and they thought somebody was writing them a blank check for the next 20 years of deciphering the Earth system. And people said, oh, well, we'll get this up and that. And in about 15 years, we'll be able to tell you which way the currents actually flow in the ocean. And meanwhile, the world is busily rising and falling and blipping. If you want to address, I might note parenthetically, we should all pray for a long, hot summer if we want to continue funding in this area. But quite, it'll have more significance in almost any event. But quite putting that quite aside, there's a constant need to communicate to society what we're finding out, and we're finding out things of value at every step of the game. NASA has joined with several of the other agencies to put out a little brochure, will come out 4 times a year. It's a journal. It's called Consequences. It takes 3 problems and synthesizes in language that anyone can understand what's happening about some major concerns: population, climate, land use, and so on. The first issue is out, and already it's gotten tremendous coverage because it contains Tom Carl's work documenting how we may actually be seeing some greenhouse signals in the United States, a climate record, and whether it's Jessica Matthews in the Post or the Times and so on and so. That's exactly what we need to do, to communicate each year, continuously, what we're finding, and not simply ask society to give us this blank check for some pie in the sky at some future time.
Mm-hmm. On that subject, I've read some articles which talk about how in the very beginning of people's awareness about the environment and its interrelationship with these other factors, we use simple words in our lexicon like poison, for example. And now as our scientific understanding has become more sophisticated, we use words like polychlorinated biphenyl. And the public is becoming more distant from what it is we're really talking about. And that complex issues are made even more complex by having a lexicon which is not very friendly. So do you think that publications of this sort, do they address that question, or is there some way to get back at kind of the roots that were much more public and hands-on 10, 20, 30 years ago than they are now?
Well, I don't think there's anything that I know that I can't explain to anybody if they're willing to take the time to listen to me. And that I can explain in language that's because I'm obviously a soft scientist. One of my fellow editors of Environment magazine is sitting out there. We, at the level of a graduate from college, at the level of a student in college, it seems to me there's nothing that we do that we can't communicate to its significance. The question is, can we go beyond that and communicate with the larger communities? I think we can, although it's very hard. We're reduced to 20-second sound bites. We're in this cacophony of voices all clamoring, and at that level, I don't know which is more scary, poisons or...
Yeah. Well, you mentioned the long, hot summer and the impact of just something kind of simple like that. There's also, I've been impressed, there's really the impact of imagery, because most, people who are not, natural scientists and social scientists understand images, and it communicates with them in a way that, the graphs and ones and zeros on magnetic tapes and things don't. Do you think that this is sort of essential in the communication, that the kinds of imagery that we're capable of showing in connection with this whole problem, that we could develop that?
Well, I think a lot about that, because when I worked on hunger, I studied if I could only capture what Rachel Carson did, if I could only capture this wonderful imagery of a silent spring which never occurred, but which these magnificent metaphors, how much more helpful it would be. But rather, before you call in the local PR person or catch the logo designers, let me make a big distinction between 2 classes of imagery. The big divide between imagery of the future is whether we talk hope or despair. And it's a constant battle. Do we emphasize the doom, the ecological dangers, or do we offer some sort of sensible path, reason to hope? I believe that in the short run, there's lots of social science evidence, by the way, on this. In the short run, you catch people's attention with pictures of doom, catastrophes, asteroid collisions, and the like. There is no evidence at all that that sustains attention. There's no evidence at all that that can motivate people for such a long-term trajectory. So yes, we need images, but I think the basic choice is to choose and choose consistently whether we want images for the long run that will sustain people, or we want images just to catch them in a very short cycle of attention.
I think that the need for optimistic images is very important, because just reflecting on the reaction of my own students to teaching about global change, they often tell me that they feel too pessimistic at the end of the class, and they also feel disempowered, and they also don't really understand what it means for their lives in specific places. And this is part of the problem, getting back to the question of what climate models can tell us. It's actually very hard to tell people about what this means for you in a particular region. What we've learned from all the research is that global change is going to be manifested in very complex ways. And I think we need to work to try to give people regional images of and local images of what their responsibility is for this change, what it might mean for them, and most importantly, what they can do to help the situation, to create a more sustainable future. And I think that that's one of the greatest challenges, is that when we're dealing with global questions, often local people don't feel very empowered to do anything about them.
Some of the most passionate global scientists I've met are our astronauts. They don't come from a formal background in the human dimensions of global change, and they come from technical and military backgrounds and all over, but they've all shared in the experience of seeing the Earth and seeing it in a way that nobody else actually has. And so when you talk to them, they have this sense of the unity of the Earth that picture communicated, but they also see and watch with pain sometimes some of the changes that human beings are making. And but they are able, because they have seen it, to communicate in ways that you and I with our fancy language cannot. They are able to communicate better than the rest of us about the beauty of the Earth and some of its vulnerability.
Do we have any questions from the audience? Yes.
From NASA teams, at the risk of introducing another variable, one of the institutions that I didn't hear you talk about very much is one that has policies and encyclicals that may go counterproductive to a lot of the wisdom that might see coming from the scientific priesthood, and that's the religious priesthood. And I wondered if you could give some comments about, first of all, if you have any thoughts about this problem that the religious side of life is not being brought into the equation, and whether or not the scientific priesthood could reach out to the religious priesthood, who are very well connected around the globe at a very local level, to bring them into the global change picture.
Well, that's a really interesting point, and there's some good news to report on that, and it comes from two ends. We were just, Diana and I were just in Durham at Duke for the first open forum, which presented results from around the world on human dimensions of global change research. And one of the pieces was an interesting piece on if you like, the ethnography of concern with global warming and global issues. And this was done by an anthropologist and not the usual survey data with lots of in-depth things. And somewhat to his surprise, although I didn't know why he should have been surprised, he found, first of all, what we find is the same universality that I described from the Gallup polls, that right across the spectrum, they interviewed people who are in Earth First, which is a deep ecology group, and they interviewed lumberjacks that had lost their jobs in Oregon as part of the set, and then Sierra Club and a variety of other public groups and so on. Almost universal acceptance of environmental values, and where he was surprised at is he found that in the most religious people for whom religion was most prominent in their lives had some of the strongest and deepest environmental values, a concern with God had created this wonderful, splendid world, and to respect God's word was to try to deal with the world as gently and as reasonably and within God's instruction, to summarize his point. So that very often we feel that people who are often fundamentalists or so on, in the to and fro of current politics, we tend to put them into sets. There's a deep set of views of stewardship that permeates, and stewardship for the earth that permeates all religious knowledge. Now, on the top end of that, there has been in the last 2 years several major gatherings of the world religious leaders. They have signed a collective statement about if you like, about the sanctity of the earth, and I had a chance to meet the Pope, for example, and along with many other people, and discuss some of these issues with him. And so I think there's a growing effort, and the effort is initiated by, of all groups, the Union of Concerned Scientists has initiated one of the major efforts to bring together the world's religious efforts.
That's fascinating. Are there any other questions? Yes, Bob.
In terms of the geographer's perspective on where the most critical areas are that should be of concern due not only to environmental problems, but the confluence of problems that relate to environment, business, ethnic concerns. What regions of the world should we really be watching most closely?
Wow. Well, our focus has tended to be, if I think of the places we talk about global environmental change, it's tended to be on the Amazon and on the Sahel. Those are the areas where people seem to have focused on as areas of crisis. But if you actually look at what's going on now, I think that one area that it's extremely important to focus on because of the dramatic political and economic changes that are taking place there is, of course, Eastern Europe and the former Soviet Union. I think that that perhaps, for me, some of the most important places are these places where there is rapid economic development, for example, in parts of Asia. I also feel that there are two other areas that we need to focus on. One is on sort of, in a sense, ecological margins where there are also people at risk, so that where we're looking at the boundaries between areas of different land covers where things are changing quite rapidly. And I also think national boundaries are important because one of the things that brings environmental change to the attention of people is when there is conflict across a national boundary, where there's need for negotiation across a national boundary. So I think that looking at the world's frontiers is important, not just to identify potential conflict, but also to build cooperation. Because in my own work, some of the strongest cooperation and hope that I've seen is the way in which institutions are working across the US-Mexican border, and that people are working in a very, very constructive way to resolve environmental problems at the level of the border, whereas at other levels it may not seem quite so positive.
Take a longer term view over I think that's a great shorter term prescription. Over the longer term, I would think there are probably 3 areas I would be most. I think the future of the world's climate is dependent on China and India. Mm-hmm. So the great populous economies, which will also be the greatest economies in the world, they'll be the greatest economies in absolute amounts within our lifetimes. The mega cities, the 50 cities will have over 10 million people in that doubled world of mine, and then Africa. I would be the 3 long-term places, but I would also put some emphasis on processes. If I look at the understudied processes that are going on, global change processes that aren't the connected form of global climate change, but are cumulative, where stuff is happening in lots of different places but adding up. Understudied is groundwater contamination, massive groundwater contamination taking place everywhere. Understudied is heavy metal accumulation in soils. Understudied are salinization and what's happening with the salts from irrigation all over the world. So those would be some of the shift in emphasis I would argue for.
I note that between you, you've listed most of the regions of the world.
We forgot the oceans.
We are interested in global change, but I'm also reminded of the question of why Americans should be interested in all of this goes back to the line of John Donne, "Ask not for whom the bell tolls, it tolls for thee."
Mm-hmm. We have a question here.
Maybe we could ask a question that stretches at least my imagination a little bit. It's been ahead 150 years, and maybe we've gone to Mars and we figured out how to do a little planet engineering, and we've got some experience with it. And also assume that energy has been captured so that it's relatively inexpensive and not 8 times the cost that we need it now for our expanding population. Can the sociological and the political systems on the globe, in your mind, figure out how to apply maybe some of those type of solutions to what we see as kind of short-term problems, the way we're talking about today? I mean, you could probably, if there's enough water on the Earth, it's a question of what its state of contamination is or its state of use. Could we adopt, with some knowledge, in your view, how to apply some of that type of technology to establish a correction for what you see as some of the problems today?
I'll take a crack at that one. It seems to me that the social scientists who will have to offer some insight into how the water that is available becomes available to all the people that need it, and that the potential for moving out and living on other planets, how we resolve that. One group who really needs to address that is the political scientists, because part of the barrier towards transferring water between regions is the nation state. Part of the question of who will get to live on the new planets will have to do with which nation states reach those planets and the extent to which we can create new forms of government, whether they're planetary or interplanetary, that decide who gets what and how we resolve use of resources. And so I think that one group that really needs to think in a visionary way, if you're looking out 150 years, is the political scientists. I think geographers are less bound by some of those nation-state issues. And I must say that in my introductory classes, when the students get too pessimistic, I give them some science fiction to try to take them out 150 years and to give them some optimistic visions of how we might break through the sustainability transitions. And I think we need to have people be more optimistic and take more risks in thinking how we can get to 150 years from now.
150 years is even too much for me. And it's because I've been affected by having seen a metaphor, or I saw a graph 30 years ago by an ecologist, Ed Deavy, that shows that essentially a series of logistic curves of population. There have been 3 great revolutions in humankind. And the first was the tool-making revolution, when we came down onto the savannas and we chipped things. And the second was the agricultural revolution. The third is the current one we're going in. Each of those revolutions opened up new technological possibilities. Population rapidly rose to fill that niche and then leveled off after a long period of time. And what I've been describing is the challenge of making this extraordinary bit of change in the next 50 years that will be needed to create that sustainable world that will carry us to this 10, 12 billion population. What you're describing is the next one, with potentials that I can't even imagine, whether it's interplanetary expansion or something of what may well be the next surge of human population and so on. But I have trouble getting beyond my next 50 years. It's probably an age thing, too. I just delivered for one of my grandchildren his paper on going to Mars. I hope you get a chance to read it.
Yes. Dr. Cates, you've moved away from the mega cities. You're living in a little place in Maine where you have a different kind of perspective on all this. And you said you bought a couple of hectares, which you're studying in depth. Instead of looking at the breadth of the whole Earth, you're really studying that in depth and seeing how it connects to this overall question. Well, can you offer us anything from that experience so far?
The most immediate thing that comes to mind is I have a little stream that runs. I live in a town called Trenton, Maine, and it's the last bit of mainland before you cross over to Mount Desert Island and to Bar Harbor and Acadia National Park. And 3 million people in summer pass by within a half mile of my house, and no one in winter. But we have a small airport that has been busily expanding itself, because apparently there's an industry that expands all airports every 20 years. In order to slow down the process, I wrote a letter to officialdom, and I said, "Do you know that I have this what seems to be like an Indian shell mound on my property?" And that apparently there's a whole set of criteria that triggered, and instantly I received registered letters after it, which I had to go to the post office to pick up. Registered letters informing me that the Indian shell mounds are protected items, and if indeed it would increase the runoff and cut into my Indian shell mound. Next thing I know, 2 archaeologists show up to investigate my Indian shell mound, and actually they're friends, so I'm glad they've gotten some work, and they came and they dug these test holes, and I discovered that my Indian shell mound was a historic garbage dump. And so there's a moral in there. I lost my mythology. I didn't hold up the project. And I'm not sure of its relevance, but that's what the immediate thought came. The larger thought is how my sense of the passages of the seasons. I just find myself overwhelmed by the different senses of time. I find myself so sensitive. We have essentially, in most of our lives, tried to minimize our sensitivity to the changes in the natural world and changes in time. And having to be closer and having more time to reflect, I pick my head up over the computer and I look at I have 2 tides a day. I think that's, maybe that gives me the perspective to look longer and harder. I'm not sure.
Okay. Well, if there are no more questions, then I'd like to thank the audience for their participation, and I'd like to thank the speakers very much for a very wonderful talks and engaging discussion, and for giving us all really something to think about. Thank you.
Thank you. Thanks for having us.